and want to welcome you to this session about Eclipse Xtend. Xtend is a programming language that is, well, made for Java developers. So it aims at making our life as Java developers a pleasure. My name is Sebastian. I'm from Germany. I'm a passionate software developer working for itemis. Itemis is a small, well, medium-sized consultancy company specialized in the automotive market and in model-driven software development. And itemis is a heavy believer in open source. Thus, we are a strategic member at the Eclipse Foundation, delegating a couple of full-time committers as, well, open source software developers. So the idea is to, well, provide added value on top of high quality open source libraries. And one of these committers, well, is me. I'm one of the co-architects of the Xtend programming language. And yeah, let's see what Xtend is. By the way, if there are any questions anytime, please don't hesitate to ask them. We have couple of times, and I'm more than happy to answer a question, so sort of an interactive session would be cool. So Xtend is a programming language that runs on the JVM. In contrast to other languages, it compiles to Java source code and not to Java bytecode, so everything is plain obvious to you as an Xtend user. You can see what the compiler does. And well, you should ask yourself at this point in time, basically every time when someone tells you that they developed a new programming language, why the heck did they do that? And that's a good question. And to answer that, I want to make a step backwards, well, not literally, but and take a look at the Java programming language. I have to confess that I like the Java platform as well as the language, so I'm probably one of the few guys here that develop new languages that still like the Java language. Why do I do that? First and foremost, because, well, it's a well-designed language, powerful, quite readable, things like that, so don't get confused by Java. There are no surprises, basically. There are top-notch IDEs out there, so I claim the top 3 IDEs in the world for software development are, well, targeting the Java language. So being it Eclipse, NetBeans, or JetBrains, IntelliJ IDEA, all these are really powerful tools that simplify our daily work. There are others as well, other tools and other IDEs, being it profilers, back-in-time debuggers, things like that. All this is available for Java, which is pretty awesome. There's a humongous amount of open source libraries out there, which are quite high quality libraries that basically solve any imaginable technical problem that you could encounter in a project. So, well, you could focus on the business things, or put it the other way around, you have to focus on the business things because all the other issues are already solved, being it mapping to databases or configuring via dependency injection, things like that. The community around Java is astonishing. So I used to say there are 10 million developers out there. Now I learned that there are 9 million developers out there that use Java. So it's probably not a trend. But all these guys are quite familiar with the Java language, with its keywords, its pros, its cons. And whenever you encounter a situation where you are surprised or you see a stack trace that you cannot figure out what it actually, well, was caused by, you can paste that thing into platforms like stackoverflow.com and you will get an answer. So the community around Java is really vibrant, and that is quite important when you think about using a programming language. So instead of using some esoteric language in order to solve a particular problem, you should really consider, well, can I staff my project with enough Haskell developers if I want to solve something, or should I probably go with Java, even though that may not be technically the ideal choice? And last but not least, there's the standard lib. People claim that it is not, well, the most well-designed piece of software in the world. So there are things like Java util date, often quoted example, or the collection libs, which are mutable per se, and people find immutable collections very important. But on the other hand, all these 9 million people that are Java developers know how to use the standard lib, and this is a value that one should not throw away. So coming back to the question, why did they develop a new language? Why do they want to supersede Java or replace Java? And the answer is, well, probably we don't want to do that. We just want to fix some issues that we have in our daily work with Java, and those are mainly, rather obvious things like string concatenation is a pain in the ass with Java. So there are plenty of template languages out there that address these issues, so that is rather obvious. The ceremonial syntax that we have with Java, so talking to the compiler that well, this is a list of strings and create a new list. Well, it should be a list of strings. And then you loop over that, and the loop variable is of type, no surprise here, it's of type string, things like that. So the lack of type inference, for example, is something that we wanted to address. So what is Xtend in a nutshell? It's a statically typed language that uses a powerful type inference mechanism. That is, most importantly, this is crucial to our strategy or to the idea behind Xtend. Xtend. It's 100% compatible to the Java language. So there's basically not a single gap, no tricks, no magic involved. Everything translates to Java source code. So, well, obviously there cannot be any magic involved. So we use Java's type system with all its dirty corners like generics and things. Well, they may not be optimal, but again, 9 million developers out there have at least a rather vague idea how that works. And well, if it doesn't work as expected, they can, well, again, go to things like Stack Overflow or put a question mark Xtend somewhere, and the compiler will no longer complain. So Xtend uses Java's type system in order to be familiar, and therefore we can leverage all these libraries out there directly without any gaps or adapter things. Another important aspect of a language is the IDE support. And thinking about Java, well, I already mentioned the top-notch IDEs that exist out there, and what we wanted to allow is implementing an IDE that can potentially achieve the same quality standards as we know from Java IDEs. So the syntax should allow to create powerful IDEs at all. So putting things in the other way around can sometimes be quite hard for IDE developers. So just simple examples here. If you declare a local variable and you want to suggest a variable name, it's quite useful to know the type in advance. Otherwise, you could not suggest that the variable name may be a list of string because it's not known at that point. And I have to say we are pretty close to what we wanted to achieve. So the Xtend IDE is already very powerful. You will see that. By the way, there will be a lot of demo after the first couple of slides here. What we wanted to encourage is a functional programming style. So Xtend is not a functional programming language. It's object-oriented. But we don't have a concept like a statement. So everything is an expression. Everything can be put into expression context, like using an if or a switch, where otherwise only a method call would be allowed in Java. And from the syntactic point, we wanted to encourage the functional programming style as well. And how could we achieve that? That is the concept of extension methods. If you has an idea what extension methods are, okay. Well, the name of the language comes from that concept, and extension methods are means to extend the API of otherwise closed classes. So taking Java util collections, for example, they have a well-defined API, and in Java 8 they do things like default methods in order to extend that. But there's often functionality that is only relevant in a certain context, in a certain layer of your application, or for a certain client of a class. And in that context, you can extend the API as well by means of extension methods. You will see in the demo how that looks like in practice. And last but not least, we come from the language designers, we come from the domain-specific language world, and Xtend should allow to interact with domain-specific languages seamlessly, as in a similar way as it allows to interact with Java. And the syntax should be flexible enough to create APIs that allow to look like internal domain-specific languages. So to put it in a few words, what we achieved is something like a clean, fast, and statically typed Groovy. Something that is not as scary as the Scala type system, and on the other hand, 100% compatible with Java in both directions. And if you know CoffeeScript, it's for JavaScript what Xtend is for Java. So basically a nice syntactic way to write Java classes, since, we compile to Java source code. Demo time. So I hope that this is big enough for you guys in the back. So this is an Eclipse 3.8 as it was released in September, so 3.8.1 or something. And who of you is familiar with Eclipse? Okay, so no more talk about perspective and workspaces. So it's plain vanilla. Xtend SDK is installed here, and what I want to do now is create a Hello World program. No surprise. So I create a new Java project, called it sample, and in that project I want to create a new Xtend class. Package greeting, class name greeter. And that should, for us Java developers, look familiar. Besides this error marker here, it tells me that there's a library missing in this project configuration, so I have to put the Xtend standard lib on the class path, which is just a small set of Java archives. First and foremost, we reuse Google Guava's utilities, so did not reinvent the wheel everywhere. And then there is this small library here with a couple of classes, I would say 25, that contain these extension methods that you will see later on. So things that are noteworthy is something that is not there, which is the visibility modifier for classes. Who of you created recently a class on the top level that was not public? Yeah, I imagined that, so no hands go up. We decided to use better defaults than Java did. Classes are public by default, methods are public by default, fields are private by default, which reduces the amount of code that you have to write, and it's not talking to the compiler but having a readable means of source code here. So let's add a main method. It looks familiar to Java as well. And then we print on the famous hello world. Now I can execute this guy, and no surprise there, prints hello world to the console. How does it work under the hood? I already mentioned we compile to Java source code, so somewhere this code is buried in this project, and I will show you where. Created a filter here to not display the Xtend folder, which pretty much mirrors the package structure of the common source folder. And there's this class greeter here that was compiled by the Xtend compiler. So pretty much pretty much what you would expect. We use a utility function here. This is from the library that we just put on the class path, and it delegates to system out println. So I can just use that in a context where an expression is expected, since this version of println returns the argument itself. So that is the idea here. Usually you would not need to have a look at the source code. But if you do, it may be cumbersome to navigate in the Project Explorer, so there's this generated code view. You can always get an idea what the compiler does and take a look on. I hope that is visible from the back. You can just select a piece of code, and it will highlight the region in the generated code that was derived from the snippet here. So that is the basic idea behind having a language that compiles to Java source code, so always being transparent, no magic, no bytecode hassles, and leveraging all the compiler checks that the Java compiler does for us, which are quite powerful. What else? Well, this Eclipse workspace was not entirely empty. There's an example project materialized here, which could have been created by means of new example Xtend examples. But I choose this version here since there's something else in there, which is the second Hello World program. And this one will be the last Hello World for this demo here. This time it's written in JavaFX, so I can just show you what it does. It creates a window with a button, and if I click the button, it changes the label. What is important about this demo here is that we have an existing Java library or framework like JavaFX and can directly work with this code. So we extend the JavaFX application class. We use the idiomatic code and the main method, which is even documented somewhere here. I don't know, I think in the launch config. There you see how you have to write this code. Okay, we did that. And we overrode a method called start that takes a stage and shall configure that. First and foremost, we allow to use the property notation in order to invoke set methods like setWidth and setHeight, or in order to invoke get methods. So as soon as your classes follow the Java Beans convention, which most classes do surprisingly in the world, you can use the more readable notation instead of explicit set and get invocations. We create a new border pane. The variable type itself is inferred from the right-hand side. We create a new button, and last but not least, we invoke setOnAction and pass a lambda expression to this method. So even though lambdas may occur in Java 8, they are already available in Xtend, and the corresponding Java code is down here. So basically what this guy will be compiled to is setOnAction with a new anonymous class called, well, it's anonymous, it has no name, a new event handler, which happens to be an interface with exactly a single abstract method, a so-called SAM type. And as soon as you have a SAM type, Xtend will automatically infer what your lambda expression should look like, or what the type of the lambda expression should be. So in our case here, we write a lambda expression that will automatically be compiled to an event handler with a method handle that takes an action event. I could make this more explicit by means of selecting the right action event and giving the parameter a name, so we could use that here, like event type. But we don't need to. it turns again out that many of these methods in so-called SAM types take only a single argument. And as soon as we only take a single argument, we can do some, I like the term syntactic sugar. Who of you attended the Kotlin talk in the previous session? Nobody. Okay. I like the term syntactic sugar because this is essentially syntactic sugar. What we do with lambda expressions that take a single argument. First of all, I could leave the type out, so it will figure out that event is of type action event. Okay, that's convenient. And I could use another variable name, which is it. Did work like a charm, okay. And it is already colored in this purplish, eclipse-ish keyword color. Actually, it has a special meaning in Xtend. As soon as you call a variable it, you may leave the receiver of a method invocation out. So it works similar to this. Instead of this.doStuff, I can always write doStuff, and instead of it.doStuff, I can always write doStuff in Xtend. And last but not least, it's rather pointless to specify that the implicit name should always be it. We can do that for you, so we leave that out. So this guy here is calling it.getEventType, as you can see down here. So that so far about lambdas. Are there any questions about that? Not yet. Okay. So let's execute this again, this time in the debug mode. Yes, I want to. Ooh, that is cool. Let me just find some estate here. So, what do we see? We see the Eclipse Java debugger, which happens to stop in our Xtend files. And we can now step into the corresponding Java code that we invoke from Xtend, inspect all the settings here, step out again. We could simply step over the Xtend methods. And if I'm in doubt what actually happens under the hood, I can even do something like show me the Java source instead. And it will do. So that is quite seamless debugging experience between Java and Xtend. Let's hit play and finally stop again in the body of the lambda expression. And here we can even inspect the given arguments. So the action event has a name it, and the event type is action. Oh, cool. And I see that on the label. So that was debugging and sort of excursion about lambda expressions. And if you happen to read my blog post by accident about this session, I promised to not sing. I will hold that promise. But to do something with beer. And there's a website called 99bottlesofbeer.net. And there you can find 1,400 and something implementations of the very same program, which prints the lyrics of a song called 99 Bottles of Beer. And these 1,000 implementations are basically in different languages, which is quite interesting. And one of these implementations is this example here. This time I annotated a method with the Java org JUnit for test annotation, so I can run this as a unit test. And it prints to the console the lyrics of the song, which goes like, 99 bottles of beer on the one, and then there are, sorry about that, it's so tempting. Then there are two special cases. If only one bottle is left, we use the word one instead of the little, and if no more bottles of beer are there, then we will want to buy new beer. So how does the implementation look like? I hope you won't get seasick from all these perspective switches. I happen to become that from time to time. Let's walk through the code. I may not leave this microphone here, so I will stick behind. Well, this program is implemented by means of Xtend's template expression. So who of you has ever used a template language in order to produce some output like HTML, source code, or something? Quite a few. So you may have experienced that templates are quite difficult to get right from its perspective. How do you lay out the template in order to, well, have a maintainable template expression or template file and a nicely formatted output? So basically the question is, where do I put my white space in order to get both right? And when we tried to answer the to find an answer to the white space question, we came to the conclusion that white space is not enough. We need gray space. So we implemented something similar to Python's indentation handling in order to identify how to lay out a template and what the developer of the template meant when he did so, or she. So what happens here is that, let me go back to the console, that everything started right at the left. So there's no indentation in the output, which is pretty much what I wanted to achieve. And the lyrics happen to require a loop, a for loop. So we embedded a for loop in this template. And for loops are traditionally indented in source code in order to make the body easier to find and things. So readability, maintainability. And this white space here is something that is only there because we wanted the template to become more readable. Thus, it is not appearing in the output. But if I indent this string here, let's say by 2 spaces, it may be visible that the first 2 characters have a gray background. So this is gray space, and gray space is relevant for the output. So let's execute this again. And you see that the second line is always indented by 2 spaces. And there's a rather smart processing behind it, which works quite intuitive in practice. So that is how template expressions address the whitespace problem by distinguishing indentation relative to control structures from all other indentation. Questions about this template expression? There should be. There's always a question about template expressions. Please.
That's not like Xtend?
Yeah, that is not the question that I would have expected. But yes, it looks like the older expand language. There was and there always is, there's still a programming language called expand, which happens to use a very similar notation in order to do templates. Well, actually, that's a predecessor of Xtend. And expand used, and we use as well, these French quotes here in order to embed expressions into the template. So there's this French quote here, and here we invoke I-1.buttles. And the common question is, how do I type these guys? And you could copy and paste them, but that's not the answer. On the Mac keyboard, they are natively available, and that's not the answer either. There's tool support for that. I can use Content Assist, and it will insert the itemis for me, which is quite useful. We are actually thinking about finding an alternative notation, but they're quite neat because actually nobody wants to write itemis into his output, so they never need to be escaped, which is really nice about those characters. Another thing that is interesting in this example here, there are actually 2 other things. We have an I, which is an integer, and the integer type does not happen to have a method called bottles. I know what you are thinking. Every type should have a method called bottles, but it happens not to be the case in Java. So we added one, which looks syntactically as if it was available on Java lang integer. But in practice, it's an extension method. That's what the orangish, reddish, brownish, whatever color here indicates. So this method is actually defined in the class bottle support down here. Now I have to navigate to the top and import it as a static extension into this file. So what happens? The method bottles takes an int primitive as its first argument, and since we make this method available as an extension method, I can now put the first argument before the method selector. So basically saying I.bottles instead of bottles parentheses I. So what it's compiled to is visible in the hover. So it's pretty much, again, syntactic sugar, but greatly improves the readability of the expression without polluting the namespace of Java lang integer each and everywhere. So it's only lexically available as an extension method. Well, uppercase bottles delegates to lowercase bottles. Lowercase bottles uses a switch expression. And that is something that is really interesting here. Switch is not a statement, so everything is an expression in Xtend. Thus, I can directly invoke a method on the result or on the return value or something of the switch expression. So it may be a string, it may be a character sequence. I want it to be a string, so I invoke toString on that. And last but not least, uppercase bottles uses the extension method toFirstUpper, which comes from the Xtend library. So there are a couple of extensions that we make available on Java's standard types like, well, integer, big integer, string, list, iterable, these things. Any questions? Cool. There are a couple of more examples. I will take this one here. It's about operator overloading. There was a time when operator overloading was considered harmful. Therefore, you have to write big decimal.add instead of big decimal plus other thing. Well, meanwhile, it turned out that operator overloading is neat. So we allow that in Xtend, which is really cool from a syntactic point, because I can do things like this here, having strongly typed values like 13 kilometers plus 2,000 meters, well, it should equal 15 kilometers. So the extension method kilometer takes an integer and returns an instance of distance. So this guy is imported here. The extension method meters works the same way. It returns an instance of distance. And now I have two instances of distance and can add them by means of a plus. So it's a binary operation that I can use here, which is just an alias for a plain vanilla method invocation. The method name is operator underscore plus. So there's a mapping between operators and method names. And as soon as your types expose a method, well, that matches the signature, you can use a binary operation instead, which greatly improves the readability. So how does it look like in the implementation? I want to say open declaration, and here's my distance class. I have operator plus, which takes a second distance and returns a new one, where my own length is added to the other lengths. I can, well, of course, use different types in my arguments, so I don't have to write binary operations always for the same types. I can say multiply works for distances and integers, well, in order to scale the length. And down here are the static factory methods that are imported as extensions.
You almost things like plus plus, minus minus.
We don't have plus plus or minus minus since they introduced something like I use the value now and change it afterwards. So it's quite different from other method invocations.
I see that you use specific words, right?
Yeah.
And then you translate them into the symbols. So, how creative you can get with the symbolic?
Question is about which operators are available, and there are a couple of things. I'm not sure that I can show them right now. I will show them later. There are things like the spaceship operator, shift left, shift right, unsigned shift things, plus equals. Quite a few things that are available that you can use. So we provide some default operators like plus, multiply, divide things that have a fixed precedence. And there's something like catch all. Here's your own space of operators that you can implement on your types. It's a predefined set of operators. No, it's currently a predefined set. So we don't want it to have this, well, here's my Unicode namespace. Please make an operator for everything. So we picked a few ones that we liked or that looked funny. Yeah. Just kidding. Times works pretty much the same as distances. So I have factory methods that are imported as extensions, and I have operators available. And now comes the funny part. Neither distance knows something about time, nor knows time something about distance, but well, it turns out that I have something like speed available, which uses both. So again, I import a static extension from the speed class here, and there's only a single method in that class, which is called operator divide, is static, takes 2 arguments, and since it follows the naming convention, I can use that method again as a binary expression here, which is this divide operator. So as soon as I have a distance on the left side and a time on the right side, I can use the divide operator in order to instantiate an instance of speed, which is pretty much the same what happens here, besides that this h thing is just, well, a no argument method. This is a very nice way to create what the Groovy guys call DSLs, so internal APIs that are very readable, very concise, very expressive in a certain context. Other questions about operator overloading or extension methods so far?
You said it's statically typed, right? So
Yeah. All this is statically typed, and if I say I divide a distance by another distance, which is not implemented, you get something like incompatible type, expected time, but was distance. So the compiler will pretty much figure out what's going on if you use the wrong types.
Yeah, so I can have more than one divide operator, right?
Yeah, you can have overloaded methods with different divides, like yeah, it will do the same thing as the Java compiler, so figuring out the best match and do that at compile time. Another example, time is running, about internal DSLs is this one here, which is an alternative to template expressions. Like sometimes you want to create a strongly typed data structure in a readable manner. In this case, it's an HTML DOM. And what we do here is a nice combination of extension methods and closures in order to have a very readable notation for object instantiation. So I say I create my root instance explicitly, and then there are a couple of extension methods available on the HTML instance. So there's a factory that allows to create, well, the head or the body, title, things, or text. And this is achieved by a nice combination of extension imports here, which don't happen to have, they can be dynamic instead of static. So you can annotate or declare a field as an extension field and make the methods available with the very same rule. So the method head takes an HTML instance and a closure, and well, creates the instance and passes that to the closure. But the point is here that I can put the instance of HTML as a receiver of the head method. And what happens here is actually something like this. So I have a closure that takes an HTML instance. I have an extension method called head. And now I can use it.head, and since it can be, well, skipped, you achieve something very readable. So that is one part of the exceptional DSL support, being able to create very creative, expressive, and powerful APIs by combining orthogonal concepts in Xtend. So there's nothing baked into the language in order to achieve this here. This thing is just the operator double arrow, for example. So no magic involved. Last example is about the standard library. And this point on my slide that read functional programming. We encourage functional programming. People think about functional programming when they think about collections often. So having a means to work with collections, Java util collections, in a more readable, more concise, more powerful way than Java does, is something that basically every given I am the Java successor programming language aims at. We combine again extension methods and closures in order to achieve a more powerful API for Java's collection types without tricking them, treating them, or changing them in any way. So what happens here? This is an example that reads sort of a database file with movie data, puts all this movie information into a list, and we want to process that list, do some data mining on that. So how is a list created? It's down here. There's movies, which is a list of movies created by a single expression, this guy here. So I say, create a new file reader, take Guava's utility method in order to read this reader into a list of strings, map this list of strings to a list of movies, where the argument type is a line, so a string. And the string is split by this separator, and afterwards I get an iterator and iterate all the columns in that file in order to create a movie instance. So all these utilities that I used here are either from the JDK or from Guava or from the Xtend lib. And afterwards I can do stuff like filter the list, and you see there's some generics kung fu involved in the actual signature, and due to type inference you don't have to hassle with that manually. So I can just say filter the list of movies. I know afterwards it's still an iterable of movie. Get the size from that, or down here sort by some criteria. So that is movie get rating actually. Takes the top 2 of them, extract the number of votes, and well, reduce the number of votes, sum that up to some long value. That is all possible due to the Xtend library extensions that we put here on the class path. Yeah.
What's the data annotation stand for?
Good question. The data annotation is something experimental that we did in the last release. You can annotate a class with a data, and what it does at compile time is creating a hash code and equals method marking your class as immutable. So you get a couple of setters, a couple of final fields, and a constructor which takes each of the fields that you have listed as an argument and assigns the values. So it's a very convenient way to create immutable, well, they are not Java beans if they are immutable, but immutable POJOs with a couple of setters and a valid equals and hash code contract.
Scala case class.
Similar to Scala case class, yeah. And this is a very nice question because it brings me to the last point of this presentation, which is sort of something even more experimental than the data annotation, and which has never been demoed before. So I've heard that all these Oracle guys praised to some demo gods here, so I won't do that. But, well. Coming back to exceptional DSL support, and summing up what is possible is, well, you saw that you can create some APIs that look rather creative, that are expressive, powerful, things like that. So that's the internal DSL stuff that you may have heard about. Then there's external DSLs, like I create a language, a small parser, and process the input somehow. That is basically how Martin Fowler described it in his book, Domain-Specific Languages. Turns out that Xtend is based on a framework that allows to create DSLs in a more powerful way, and all languages that are created with this framework, it's called Xtext, somewhere here, should it be readable, turns out that Xtend interacts nicely with all Xtext-based DSLs. So pretty much what you saw about calling out to Java, calling out to Xtend from Java, I didn't demo that, it doesn't matter, works the same way if you use Xtext-based domain-specific languages. But there's one thing more that falls into the category of exceptional DSL support, which is annotations on steroids. So if you take a look at Groovy AST transformations, probably heard about those, or if you think about how some annotations are used in Java, they are sort of a way to attach additional information to structures of your language. So marking a class as an entity, something like that. And then there is, since 1.5 and far improved in 1.6, something like annotation processing. This is taken from an Oracle documentation. So annotation processing in a nutshell is basically a set of reflective APIs that are based on your source code where you put your annotations into. You can query for the types in that source file and create new source files from that. So basically, take this source code here. I've compiled that to a class. Now you can inspect the class file and create other source code files from that. So let me compile those again. Which implies that you cannot change the way how your class that you annotated itself is compiled. Of course, there are ways, and I've learned yesterday in some BOF that you can even do cool tricks like introducing a new super class and a subclass and basically eliminating your actual class, but that's something that I won't do. But what I want to do is, of course, manipulate the annotated element itself. The annotated class, annotated method, annotated parameters. And this is something that we are allowed to do in Xtend since we have this intermediate Java representation. So we are compiling from Xtend to Java bytecode, and we are basically in full control of what happens in the first step. So how do I transform, how do I compile the Xtend file to Java source code? And this is something that we call in Xtend active annotations, which allow to participate in the compilation process live. No need to deploy anything. You can do that live. You can enhance the derived source code, and you can apply constraints that are directly evaluated in the editor and give feedback to the user. And I have a couple of minutes left to give again a demo. And, well, great. This time in this Eclipse here, which is the experimental one. And there's a project called Demo, which contains demos. first one is a very, well, the most simplistic example that I came up with. I was not too creative. It's about serializability in Java. So that is the most simple serializable class that did not, well, yell at me. So if I leave the serial version UID, Eclipse will complain that my class does not define the serial version UID, which is sort of annoying because I'm not interested in that UID, but for some reasons, probably for good reasons, the compiler is. This is just an example of a constraint that is implied that I don't want to maintain or fulfill manually every time. So how does it look like if I want to create a serializable class in a more concise way? So having the possibility to participate in the compilation. I have an Xtend file, which is called sample. I have the corresponding Java class. And I have a file with the extension macro, which is an annotation processing language. Yeah. So, what does this? I hope you can all see that. So, what happens here? In the macro file, I define an annotation called @serializable in the package serialization, and this annotation is valid for, well, classes. I could say it's valid for methods, parameters, all that stuff, things like that. And whenever the Xtend compiler encounters such an annotation, it should process that thing that is annotated, which in our case is a number of Xtend classes. Yeah, there it is. And for each of these classes, I want to do something, which is this code snippet here. So take the class that was compiled. So find a Java class with the name of the Xtend class. So it's Xtend type get name in this package here. Basically, find me the corresponding Java class. APIs is still subject to change. Yeah. And what I want to do is add the interface to the list of implemented interfaces. So I say supertypes plus equals, give me the type of serializable. Let's save this guy and let's add the annotation here. And after I hit save, you have probably recognized, that was the first, that something changed on the right-hand side. So I get the implementation thing here, which is quite okay, but not what I actually wanted to have, because I am keen on this serial version UID thing. I've read that is important, so I will do that. I could, of course, make something like give me a value called serial version UID, which is a long, and I could save that and I get something here. But it turns out that this serial version UID should be protected and final. At least that is what Eclipse generates for me. So I want to validate that my manually defined serial version UID fulfills these constraints. So I can say, give me the members filtered by all fields. That have the name and I'm a poor typer, so I have this name here and it's my field. And if there is such a field, I want to validate that it's static and final. So if field is static or field is final, so now I have to say if not. If it's neither static nor or not final, so that is something that I want to do. I want to create an error marker on the field and say has to be static and final. And I hit save, and I get an error marker. without any further ado, which tells me that something is wrong here. So, okay. So if it knows that this field should be static and final, it can, of course, create that field for me. And this is what I prepared down here. So after I've added the super type, I want to add a field. And that is something that I need to add. Damn it. Let's make this full screen as far as I can. So create a field called serial version UID of type long. Make that static, make that final. And this is preliminary, but compile the initializer as 0 or better 1 dot, well, as a long. So if I save this guy and refresh the editor, I will see that it creates the right serial version UID for me on the fly. So I could even put, well, some sophisticated compute that thing from the signature of the class and something. So far so good. Of course, there are more powerful use cases for that. And so last demo here, I have to close all these manually. Yeah, there's a question.
So how do you recognize the serialized code macro will be used to process the serialized by annotation? By convention?
The annotation is a special kind of annotation, so it's a macro annotation, and as soon as you annotate a structural concept with that macro annotation, the compiler will pick that up. And that is not hardwired into the language Xtend itself, but it's provided by an Eclipse extension point. So you could even hook into Xtend by means of other compilation participants doing something like all the JUnit 4 annotations require that, well, add before class requires a static thing with void and public, and I want to validate that. That is possible as well. So GWT requires these 3 classes everywhere: synchronous interface, asynchronous interface, implementation class. Synchronous interface is slightly different from the asynchronous one, and there's a couple of tools that keep that in sync for you, but you have to use those tools. And what you could, of course, do is, well, create an annotation called GWT service and let that stuff happen under the hood for you. So it will create a synchronous interface from the public signatures of the class, the async interface as well, copy the member declarations to that, add the implementation clause, and that is something that is powerful enough to, well, create a very seamless experience when you're working, for example, with frameworks like GWT that require you to have a certain amount of abstractions in place. So how is that compiled to Java? I have this process string in a class called test, and I get test interface async with this async callback here. Test interface with process string, and well, the actual implementation now extends test interface. And I can, of course, do things like override string process boolean b, and that is b dot to string or something, and I will get that here and the signature in the interface and things like that. Everything live, so there was no deployment or something involved. I have 30 seconds left. No, just kidding. If you have any questions, I will be around here like until Thursday, most likely in all these emerging languages sessions or Java VM sessions, or at the coffee bar, most likely at the coffee bar. So approach me and, well, ask questions if you are curious, or I don't know. Thank you.